Hello everyone, this is Bini. In this video, we'll discuss about understanding ferrites. To understand ferrites, first we must know what is a magnetic material. Magnetic materials are materials which get magnetized in a magnetic field. These materials will have an ability to create their own magnetic field in the presence of external magnetic field. So, those materials which do not have a magnetic moment but a permanent magnetic moment are called diamagnetic materials, and those materials which have permanent magnetic moments will be classified into paramagnetic materials, ferromagnetic materials, antiferromagnetic materials, and ferrimagnetic materials, which is also called as ferrites. So paramagnetic materials will have ununiform magnetic moments, whereas in ferromagnetic materials the magnetic moments will be parallel and have the same amplitude. In antiferromagnetic materials the magnetic moments will be antiparallel to each other and have same magnitude, whereas in ferrites the magnetic moments will be having antiparallel magnetic moments and different magnitudes. So the other term used for ferrimagnetic materials is ferrites. Ferrites will be formed by modifying the structure of a iron oxide, and without any inclusion of carbon it will have one of the iron atom replaced by different transition metal. These materials have antiparallel magnetic moments of different magnitude, giving rise to a large magnetic moment in the presence of external magnetic field. The susceptibility of ferrites will be very large and positive. There is, beyond a temperature, a ferrimagnetic or antiferromagnetic material will become paramagnetic material. Those temperature is called as Neal temperature. This is the structure of a ferrite. The general chemical formula of a ferrite molecule will be M2 plus Fe2 3 plus O4 2 minus. So iron oxide Fe3O4 will be having one of its iron atom replaced by a M2 plus ion, that is a divalent metal ion, like example zinc, iron, magnesium, manganese, or cadmium. This is a structure of a ferrite. Generally, this ferrites will crystallize to form a cubic structure. So each corner of a ferrite unit consists of a ferrite molecule. So there will be two sites called as A site and B site. You can see the figure representing a ferrite. So therefore in a ferrite unit cell there will be 8 molecules. So there will be 8 divalent metal ions and 16 ferric ions and 32 oxygen ions in a single unit cell of a ferrite. For if only oxygen atom ion is considered, then you can say that it is a closed pack face centered cubic structure. So there will be two sites named as tetrahedral site, which is the A site, and octahedral site, which is the B site. So A site plus B site and an oxygen ion will form a ferrite molecule. So this is a representation of an octahedral site, which is pale blue color, and the violet color represents the oxygen ion, and the pale red color represents the tetrahedral site of ions. So for every 4 oxygen ions, there are 2 octahedral sites and 1 tetrahedral site. So based on the distribution of A site, which is the tetrahedral site, and B site, which is the octahedral sites, ferrites can be classified into two types, namely regular spinel and inverse spinel. Usually the number of octahedral sites will be twice the number of tetrahedral sites. So regular spinel will be materials in which the each divalent metal ion occupies one tetrahedral site and each trivalent metal ion occupies one octahedral site. So there will be 8 tetrahedral sites and 16 octahedral sites. A sites and B sites combine to form a regular spinel ferrite, which is having a structure as shown in the diagram, and the 2 represents divalent ions and the 3 represents trivalent metal ions in the structure. So zinc ferrite is a typical example of a regular spinel structure. Whereas inverse spinel structure, it will have half of the B sites, that is 8 sites are occupied by divalent metal ions and remaining half, which is again 8 sites, will be occupied by B sites, and all the A sites are occupied by the trivalent metal ions. As you can see in the diagram, all the 3 represents trivalent metal ions and 2 represents divalent metal ions, whereas the shaded spheres represents oxygen ion position. Applications of ferrites. These ferrites are used in radio receiver to increase the sensitivity and selectivity of the receivers. These ferrites can be used in cores, in audio and TV transmissions. Ferrites are used in digital computers and data processing circuits. Ferrites are used to produce low frequency ultrasonic wave by magnetostrictic principle. Ferrites are widely used in non-reciprocal microwave devices. Examples for non-reciprocal microwave devices are like gyrator, isolator and circulator. Ferrites are also used in power limiting and harmonic gyration devices. Thank you for patiently listening to the video. I hope it is useful to you. Thank you.